Hello, this is Mrs. Huntley. We are in Module 1, Lesson 3, Numbers in Exponential Form Raised to a Power. You should be on page 15 of your module, and your essential question for this lesson is how do I write an equivalent expression or equivalent expressions for exponents that are raised to a power? So we're going to start with a little review. When you were learning how to multiply numbers, it might have been described to you or explained to you that it was a shortcut method of showing repeated addition. So multiplication is a shortcut for repeated addition. Now there are 4 3's being added together, so we can say this is 3 times 4 plus 3 times 4 plus 3 times 4 plus 3 times 4. Okay? Or we could even simplify it further and say it's 12 plus 12 plus 12 plus 12 plus 12, or 12 times 5. That's again showing repeated addition using multiplication. Now exponents show repeated multiplication. So in the example right below it, we've got 3 times 3 times 3 times 3. That's going to be 3 to the 4th power. Then we're multiplying that times 3 times 3 times 3 times 3, which is again 3 to the 4th power, times 3 to the 4th power, times 3 to the 4th power, times 3 to the 4th power. Now how many times are we multiplying 3 to the 4th power times itself? Let's see, I'm going to switch colors so you can see me counting. 1, 2, 3, 4, 5. So I've got 3 to the 4th power being multiplied 5 times. By itself, 5 times I should say. So let's count up in our original example, our expanded form of the repeated multiplication, how many times there's a 3 there. So we've got, I'm going to cross them off with green. You don't have to cross them off in your book. I just want you to be able to see what I'm doing. And since you can't see me pointing to something, I need to make a mark. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know that this is 3 to the 20th power. Do you see any kind of a shortcut that we can take looking at the notation that we have of 3 to the 4th power raised to the 5th power? What shortcut could we take? Instead of having to expand it all out and count up all those 3's, what could we do? Hopefully you're recognizing that 5 times 4 is 20. So I could say that this is 3 to the 20th, or I'm sorry, I should say it's 3 to the 5 times 4 power, 3 to the, or 4 times 5 power, which is equal to 3 to the 20th power. That's where we're getting those numbers from. So example number 1 is the same problem again. So 3 to the 4th power raised to the 5th power is 3 to the 4 times 5 power, which of course is 3 to the 20th power. Our next example, 7 to the 2nd power, or 7 squared raised to the 6th power. How would I go about doing that? So why don't you take a minute and see if you can answer this one yourself, and I'll catch up with you in just a second. So write down something. We're going to keep the base, and we multiply the exponent on the outside of the parentheses by the exponent on the inside of the parentheses. So 2 times 6, or 7 to the 12th power. Example 3, 1 1/3 to the 3rd power to the 10th power. So again, exponent on the outside multiplied by the exponent on the inside. I'm going to keep my base. (1.3) or 1 3/10 to the 30th power. So the algebraic rule, x to the m to the nth is x to the m times n, because, now this is where I'm going to have to expand it out using symbol notation. X to the m to the n, what does it mean? I'm going to have x times x times x, m times all raised to the nth power. That means it's going to be repeated over and over again. Hopefully that makes a little bit of sense. On your own exercises 1 through 4, I don't see any weirdness here that would preclude you from being able to do this. So, oh, you know what? Maybe exercise 2. Let's do exercise 2 together, and then I'm going to have you pause the video and do the other ones together. So exercise 2, I've got -2 raised to the 5th power, raised to the 8th power. The reason this one looks weird is because it has a double set of parentheses. Remember, when you have that negative and you want whatever's on the outside of the parentheses to be applied to both the negative and the number, you have to put it in parentheses. So a double parentheses is not that odd. So again, 8 times 5. Keep my base of -2. Again, it has to be in parentheses. Multiply 8 times 5, or 5 times 8, either way. So it's going to be -2 to the 5 times 8 power, which is -2 to the 40th. Oops, I can't write. Okay, so at this point, I would like you to pause the video and write your answers for exercise 1, exercise 3, and exercise 4, and then unpause the video and check your work. Pause it. Okay, so check your work. Number 1, you should have 15 to the 27th power. Number 3, you should have 3 4/10 to the 68th power. And number 4, or exercise 4, you should have s to the 68th power. That's just showing you the difference between exercise 3 and exercise 4 is just showing you that it works for numbers and it works for variables as well. Okay, next page. Sarah wrote 3 to the 5th power raised to the 7th power is 3 to the 12th power. Correct her mistake. Write an exponential expression using a base of 3 and exponents of 3, 5, 3, 7, and 12 that would make her answer correct. Okay, so this is a little bit confusing. First of all, hopefully you're recognizing her mistake right off. She added her exponents instead of multiplying them. What she should have done is multiplied her exponents. So this should be 3 to the 5 times 7, or 3 to the 35th power. That's what would have been correct with the way the problem was presented. So when a power is raised to a power, Sarah should multiply the exponents. Now they're asking us to write an exponential expression using a base of 3 and exponents of 5, 7, and 12. That would be correct. 5, 7, and 12, that would be correct. Now, when do we add our exponents? When do we add our exponents together? Isn't it when we are just multiplying with the same bases? So we would need 3 to the 5th power times 3 to the 7th power, and that would equal 3 to the 5 plus 7 power, or 3 to the 12th power. Two different things. See how this is just multiplying with the same base, and this is a power to a power. Let's skip exercise 6. I don't like that one. Okay, this next one, it's another exponential rule, but it's one that we've actually talked about. So when we have multiple things inside the parentheses and the exponent is right outside the parentheses, that means that exponent has to hit everything inside the parentheses. So this would be x to the n power y to the n power, because the exponent is on the outside of the parentheses. What this means is, well, okay, because, so it means xy times xy times xy times xy, however many times n is. So it has to hit both things inside the parentheses. So I'd like you to take a note here. Whatever exponent is outside the parentheses must be applied to all of the bases that are inside the parentheses. And we can give a couple of examples here. The first one is kind of like the example, well, it is exactly the example that was given up above. So example 1 is when you have xy and it's being raised to some power, that's equal to x to the n power, y to the n power. Then if you have something like a fraction, say that we have x, here's example 2. So we have x over y, and that's in parentheses, and it's being raised to the n power. What that means is x to the n power over y to the n power. Hopefully that makes some sense to you, and this is not too terribly confusing. I know keeping all of the rules straight is a little bit challenging, but I think you can do it, and we're actually going to make a graphic organizer in class that should help you keep everything straight. So let's take a look at the on your own exercises. Exercise 7, 8, 9, 10, 11, and 12. And what I'd like you to do is go ahead and attempt these and then come back. You know what, actually, let's do 7 together really quick so that you understand what the expectation is. So we've got 11 times 4, and then we have it in parentheses raised to the 9th power. That means this 9 has to hit everything inside. So if I was rewriting this, I'd say it's 11 to the 9th power times 4 to the 9th power. Does that make sense, what they're looking for here? Hopefully it does. I would like you to pause the video. You know what, why don't we come back after each one? So pause the video, try 8, come back, check it, pause the video, try 9, come back and check it. Why don't we do it that way so that I'm sure you're on the right track instead of you doing a bunch of them and then coming back. So pause the video. Okay, so the first one is 3 to the 10th, 7 to the 20th, then 9. Okay, go ahead and pause the video again, see if you can work through this on your own. Okay, so exercise 9 would be 3 to the 10th, 8 to the 20th. Is it starting to make sense now? Exercise 10, pause the video. Exercise 10 would be 5 to the 7th times x to the 7th. Exercise 11, getting a little trickier. Okay, so exercise 11 would be 5 to the 7th power times x to the 7th power times y to the 14th power. And the last one, exercise 12, please pause the video and see if you can do it, and then unpause it and come back and see if you did it the same way I am. Okay, so a to the 8th, b to the 4th, c to the 12th. Okay, so we're going to skip exercise 13 as well, and I'm just going to summarize the lesson real quick. To raise a power to a power, multiply the power on the exterior of the parentheses by all of the powers inside the parentheses. Kind of like a distribution, kind of like a backward distribution. Be cautious. You know what we didn't do any examples of is when it's a fraction. So if you have a fraction, I'm going to do it with numbers instead of letters there. Say you have a fraction like this. We've got 3 to the 2nd power divided by 5. And we're raising that to the 4th power. This 4 is going to hit everything inside. So it'd be 3 to the 2 times 4 over 5 to the 4th power, or 3 to the 8th power divided by 5 to the 4th power. Now, because our bases are different here, we can't simplify any further. That would be as far as we could go. And 3 and 5 are both prime numbers, so it's not like I could break them up. So that is the conclusion of lesson number 3. I'm just over 15 minutes. I hope you enjoyed this, and I hope you enjoy the rest of your evening. I'll see you next time.